Yeah, there's some things.
Actually, I think I got it.
All right. So you know what time it is?
Free response.
It's time for free response roulette. Yes, there it is. I know, I'm excited. All right, so let's spin this. 2010, number 5. All right,
That's a good one.
I know, that's an oldie but goodie.
This question is no.
Number 5. Oh, this is actually a famous question. When this question came out, they called it the Snoopy question because it kind of looks like Snoopy laying down with his nose on top of his thing.
Yep.
No?
That's it.
Okay. Now, this is what the writers called it, the Snoopy question. All right. So this is the Snoopy question. All right. So they're telling you we have this graph of G prime, and we have a differentiable function G. And we have an initial condition, G of 0 equals 5. And it says that's it. Okay, so first we have to find G of 3. So how do you do that? This is not G, this is G prime.
What you would do,
FTC part 1. So G of 3 is just G of 0 plus the integral from 0 to 3 of f of G prime of x dx. Right? So this is G of 0, which is 5, plus the integral from 0 to 3 of G prime. So this is just a geometric problem, right? It's going to be a quarter circle, which is 1/4 pi r squared, 1/4 pi r squared, plus a triangle, 1/2 base times height, 1/2 base times height. Done. Don't evaluate. I know it's not satisfying just from, a natural tendency. You want to simplify that, but don't do it. Okay. G of -2, same thing. G of -2 is G of 0 plus the integral from 0 to -2 of G prime of x dx. And again, this is all the work you have to show. You got to do a setup. You can't just start writing formulas down. You got to actually write how you got those formulas. So this is going to be 5 plus, now you're going from 0 to -2, which is backwards. So it's going to be the negative sign, right? So it's going to be -1/4 pi r squared. That's it. Because now we're just talking about this quarter circle right here, but the negative sign. That's part A. Any questions on that? Part B, find the x-coordinate of each point of inflection of G between -7 and 5. So how do you find points of inflection, just generally, how do you find points of inflection of G? It's when the second derivative changes sign, and there's one other requirement. No. Not necessarily. I mean, yeah, I guess it does. No, I don't think it has to be. It could be undefined. Second derivative could be undefined. But the second requirement is that the function has to be continuous at that point. But that's already taken care of because they tell you that G is differentiable. Okay? If you have a function that's not continuous at that point, then it's not a point of inflection, even if the second derivative changes sign. Okay, so we need to know when the second derivative changes sign. How can you identify points like that based on the graph of G prime?
Steve, what you just said.
How can you look at the graph of G prime and tell when G double prime changes sign? yeah, when the slope changes from positive to negative, I would actually just, if this was my test that I'm taking, I would do a first derivative test on this graph, which would be really the second derivative sine chart. But I would do it just coinciding exactly like with the function itself. Like I'd say this is g double prime sines, and you can see it's increasing, and then it's undefined. So I'm actually just going to put a point there at -2, and I'm going to say it's positive, but then it's positive again. So it's 0 at 0, and then it's positive again, and then it changes to decreasing. So from 0 to 2, it's decreasing, and then it's increasing again up to 3, and then it's decreasing. So this is concave up, concave down, up, down, like that. So points of inflection are at x equals 0, x equals 2, and x equals 3. Does that make sense? So this is at x equals 0, 2, and 3, and you have to give a reason, since g double prime of x changes sign, and g of x is continuous at these x values, or at x equals 0, 2, 3. So there's a complete explanation. Okay, you have to have words. It says explain your reasoning. So you can't just have a sign chart and say x equals 0, 2, and 3. You got to have words. C, the function h is defined by g of x minus 1/2 x squared. Find the x coordinate of each critical point of x. How do you find critical points? What are critical points? It's where the first derivative is 0 or undefined or endpoints. Critical points are 0 derivative points, undefined derivative points, endpoints. So we have this function, h of x, g of x, minus 1/2 x squared. So h prime of x is equal to g prime of x minus x, right? So if you're trying to figure out when this is 0, how do you determine that? How do you solve that for x? Any ideas?
Well, this would be where, you know, g prime is the same as, right?
Okay,
That's why
so
the slope is this. They just work out, right?
what do you mean? What do you mean when the slope is the same? This is the graph of g prime. What does the graph of y equals x look like? It's just a line with slope 1. So it looks like this. They just want to know when they're equal. There's 2 points. There's 1 point right here, and there's 1 point right here. Okay, I'll do the hard one, 3, 3. How do you find that point of intersection? Or I should have just said x equals 3.
Without your calculator?
Yeah. This is a non-calculator question. Number 5 is definitely a non-calculator.
Well, you have the
You have to use like a circle formula.
distance.
Okay. What do you, okay, so what is it?
I don't know.
Okay.
I don't know.
And what are you saying? Distance?
Yeah, so maybe it's about.
Okay.
I was gonna say what Paul said.
You were going to say what?
I was gonna say what Paul said.
Well, actually, you know that they're the same, like it's gonna be like 1.5, 1.5 or something like that.
Something like that. I agree.
So, would it be 1.5, 1.5? That's what it looks like.
Well, I mean, just if you think about it, if it was 1.5, then the distance formula would have to work. So you'd have to take the square root of 3 halves squared plus 3 halves squared, and you'd have to get 2. And I don't think that's true. Is it? This is 9 fourths plus 9 fourths, 18 fourths. If you square root 18 fourths, you don't get 2. But I think you're on the right track. Anyone else have an idea how to get that x value? This isn't a unit circle. It's a circle of radius 2.
Why does it?
Maybe?
Yeah, because that's equal to, and you just sub in x for, I want to solve for x. You sub in x.
Sub an x to what? What do you mean?
For the distance one, for x and y.
So 2 equals square root of x squared plus x squared?
Yeah.
Sure, you do that. So 2 equals the square root of 2x squared. So 2 equals radical 2x. X would be 2 divided by radical 2. I agree. 2 divided by radical 2. Now, another way I could have gotten this is just use trig. Like I know that this is x, and this is also x, and this is 2. I could have just done the distance form, the Pythagorean theorem, or a trig. Like I know it's a 45, 45, 90 right triangle. So in general, if I know the length of the hypotenuse, I just divide by radical 2 to get the length of a leg, which is 2 divided by radical 2. Or I could have just done the Pythagorean theorem, x squared plus x squared equals 2 squared. Does everybody understand that? So these are our 2 points that are critical points. All good with that? That was kind of the hard part of this question. Then it says, classify each critical point as the location of a relative min, a relative max, or neither a min nor a max. How do you do that? You could do a sign chart. Yeah, a sign chart would just be, you're doing a sign chart for each prime, so you'd have to somehow determine whether each prime is positive or negative. But let's think about this like at a random point. Like let's say at x equals 0. No, 0 is not a good choice. I think this might be difficult to do the first derivative test for, just because I have to first identify points where h prime is undefined, and also, I don't know, what do you guys think? Let's try it. Let's do a first derivative chart. H prime. So my first derivative chart would look like this. This is -7 and 5. I know that there's critical points at 3 and 2 over radical 2. This is 2 over radical 2 and 3. Okay, so now I'm just having trouble like figuring out how to do this. So if I pick a point in here, what would be a nice convenient point to pick? 0 would be a nice convenient point to pick. If I substitute 0 in, I get what? Get 0. So why didn't I come up with that as a critical point?
Yeah, I'm really plugging 0 into each of those. We don't know what G is here.
No, you're plugging into h prime. See if it's positive or negative, right?
You know it's going to work because when you look at the graph, you see when x equals 0, and obviously it's 0.
Oh, yeah. No, wait. I'm confused. Well, why didn't we get 0 as a critical point is my question. Why isn't 0 included in this list if it gives you a 0 derivative? Why is that? Because look, this line, y equals x, only intersects this g prime at 1 point, or 2 points, these 2 points, not at 0, right? They don't intersect at 0. So why is 0 a critical point? Or why didn't it come out as a critical point like it should have?
It equals 2, not 3.
How does it equal 2? Oh yeah, this is G prime. It's G prime is 2, it's not 0. G double prime would be 0. Thank you very much. Okay, so this would be 2 minus 0, right? So this is positive. Okay. All right, so far? Then pick a point, like pick 2. If you pick x equals 2, you get 0. G prime is 0 at that point. 0 minus 2, which is a negative number. So this is working fine. First derivative test working fine. And then if you pick 4, it's the slope of this line, which is negative 5 halves, right? Slope of this segment is negative 5 halves minus something, so it's negative also. Do you agree? It's negative 5 halves minus 4, which would also be a negative number. So, did I mess up again? Go ahead.
Yeah, I'm just confused. So at 4, isn't it just whatever the point is?
Yeah.
At 4, oh yeah.
I did it again.
Yeah, thank you. I did it again. I was looking at this as the graph of G, not as the graph of G prime.
Otherwise, that's so negative. Okay.
Is it? Right, so if I take this, so that's like 1 minus 4, yeah, it's still negative either way. The good part about a sign chart is the readers don't see your analysis. So if you get the sign chart right, you get the sign chart right. But still, it's best if you're not guessing like I just did. Okay, so to classify these critical points, oh, I forgot something. What did I forget? Oh, endpoints, but they won't be included anyway because it says not to include them. But if we had to include them, -7 is a min, and -5 is also a min, right? So to classify these points, at 2 over radical 2, there's a relative max based on first derivative test, and at 3, it's neither because it's decreasing then decreasing. So the explanation would be it's a relative max because H prime changes from positive to negative at 2 over radical 2. It's neither here because H prime is negative on both sides of x equals 3. Does that make sense? My first instinct here was to do the second derivative test. So does anybody remember how to do the second derivative test? We just did the first derivative test on H prime. Does anybody remember what the second derivative test is and how it works? The second derivative test says that if the first derivative is 0 and the second derivative is positive, then it has to be a min, right? Because it's concave up. If you have a 0 derivative point on a concave up function, it has to be a min value. If the first derivative is 0 and the second derivative is negative, it has to be a max. You remember that? So that was my first instinct here. I'm looking at this graph, and I'm trying to determine the sign of the second derivative if I'm doing the second derivative test. So, like, for example, if I took h double prime of x, it's really just g double prime, right? So if I look at g, because this is h, it's derivative, oh, minus 1, sorry. That's h, the prime, so this is g, or h double prime. So if I took h double prime of 2 over radical 2, it would just be g double prime of that, which is -1, minus 1, which is a negative. So it's a concave down function where the derivative is 0. This has to be a max point. Do you see how that works? That's the second derivative test. If I took h double prime of 3, oh, here it's undefined. So the second derivative test is inconclusive if double prime happens to be 0 or undefined at that point. So it wouldn't have worked. But this was my first instinct, was to do the second derivative test in this case. Does everybody understand what I'm saying? So there's two ways to determine maxes and mins. First derivative test, which is just to determine the signs of f prime. And if it goes from positive to negative, it has to be a max point. If it goes from negative to positive, it has to be a min point. And then there's a second derivative test where you look at 0 derivative points and then the sign of the second derivative to determine if it's a max or a min based on concavity. You understand? Okay. So the second derivative test would have worked for 2 over radical 2, but it would not have worked for x equals 3. Any questions on that? Okay. Now, for today, I actually don't really have anything new to talk about, but there is a homework assignment, and it's just based on, I'm going to give you the rest of the period to work on it, but it's just other types of contextual problems, like looking at a problem and figuring out what the units of the answer should be, looking at a problem and interpreting the meaning of a derivative or a meaning of an integral in the context of an actual real-world problem. So that's what the homework deals with. There's like drop-down menus. You have to like pick units. You have to pick, what a particular expression means or whatever. So I'll just give you time to work on that because I think that's just a better use of your time. And then you don't have any homework. Any questions? All right, I'm going to stop recording. And the homework's just called Other Contextual Problems.
Can I go see if Mrs. Cleveland is here? Is that okay?
Yeah, sure.